So the context when A123 was looking at its first battery technology was framed in the following way. Batteries are essentially electrochemical, mechanical devices. You have a terminal with a positive, another terminal with a negative. Inside, you have essentially a jelly roll construction of the anode and cathode constituents. I've got a micrograph shown here that gives the basic length scales of the components in a lithium-ion battery. Cathodes are typically 100 to 200 microns thick. What you see there are individual particles like grains of sand. They're essentially bound together with a polymer binder. If you put in a polymer binder, some conductive carbon fufu dust to improve the electrical conductivity between the particles, and if you bond that electrode to a metal foil, you create these long metal foils of cathode, long metal foil of anode that has this material on top of it, a thin polymeric membrane that's called a separator that's electrically isolating, so it's a polymer, it's plastic, it doesn't conduct, and you wind those three components together in a jelly roll. You then imbibe that system with an electrolyte which permeates the pore space between the individual particles, moves through the porous membrane, and allows a lithium salt to move back and forth during charge and discharge. That, in essence, is a lithium-ion battery. If you think about making these devices, it's actually a complex, highly engineered device and relatively expensive. When lithium-ion batteries first came out in the 1990s, the battery itself, just a small little battery that you can pop out of your cell phones these days, would be $10 or $20 to the cell phone provider. Now they're about a few dollars, so there's been very dramatic cost reductions over the years. At the time that A123 was looking at entering the space, the overall value of the material in the battery was about 25% of the whole package. The rest of the package would be the metal can, the separator, the metal foils. So we felt that there was a very big opportunity to come in with a big idea and change that basic proportion of value-adding materials, the anode and cathode, compared to the packaging materials that are used to hold the battery together. So this was the big idea. This is this founding idea of A123 systems. It utilized nanoscience, and essentially through proper engineering of the various anode and cathode particles and essentially the electrolyte system that would separate the two, the idea was that you could mix a single slurry of the constituents. You take all your cathode particles, all your anode particles, your precursor to your electrolyte, and you mix it in essentially a giant pot. You cast this thing out onto a sheet, and the battery would form itself. It's kind of a wild idea, and it was fun to talk about and work on in the early years. And the structures that would result with success of that technology are shown here. And you have a very different structure. You have these interpenetrating networks of anode and cathode, but they never short circuit because you've engineered the particles properly. It has to do with essentially colloidal surface forces and engineering those at a particle-to-particle level. And you're starting to see where we got our company name, the A123 there. And I'll talk about that in the next chart. But the basic idea that we went forward to the investors with success of this approach, we could double the energy density, significantly reduce the manufacturing cost, create a new battery architecture that would result in a revolution in the industry. This idea came out of MIT. It was in Yetming Chang's laboratory. He's a professor of material science there. As we were forming the company, we negotiated the exclusive worldwide license. And so we were talking about this self-organizing idea in the springtime frame as he was moving it forward in his MIT lab. Way too risky for me to quit my day job at that point, so I stayed put at American Superconductor. There's a third co-founder, a guy named Rick Fulp, and if you've met him, he's a remarkable guy. At the time, he was 26 years old, and he had already founded 5 or 6 companies. None have been a really huge commercial success, but he has had some business success before A123, and he certainly has a lot of chutzpah. So he had, this is 2001, right after the bubble had burst, and he was looking to go from the IT sector, where he had been involved mostly, to go into a totally new space. The new space he wanted to get into was energy and nanomaterials, and he came up with this idea that he'd form a carbon nanotube battery company, and this guy is a piece of work. When he got that idea, he would go over to MIT and just knock on professors' doors, senior MIT professors, and go, I'm Rick Fulop. I want to start a battery company on carbon nanotubes. Will you join me? And when he met with Yet goes, no, 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 I have a better idea. And so that's what ended up being the founding team. Rick, because of his entrepreneurial experience and ability to create a deal, me with the industrial know-how to take ideas and turn them into products, and Yet with the ideas. So we met at Naked Fish in Natick. We put together a pitch during the month of August, lots of late nights at the Dunkin' Donuts in Natick right down the street. First pitch in September. In October, we had multiple term sheets. We had a lead term sheet for an A round from Northbridge, another one from Battery Ventures. We had licensed the IP by that point. And so I thought, okay, so it's getting serious. So I quit my day job in November, and we hired our first employee, paying him before the deal had closed, paying him from our personal checking accounts. By the way, Ben is still with us. December, we closed our first round, and it was a true A round with $8.3 million. The original plan, the product was self-organized batteries with a 2x energy improvement opportunity. Manufacturing, because of this idea of just mixing a single sauce, casting the sauce onto a metal foil and having the battery make itself, we didn't need all the capital infrastructure of the conventional battery industry. And in fact, through contract electronic manufacturers, we had a viable model that would keep our capital structure low and leverage an existing manufacturing base. So the VCs liked it, we liked it, and so that was the basic manufacturing model at that point. Customers, we were going to aim at the consumer electronics space. We were going to use the same basic chemistry they were, just do it differently. And so we were a perfect play for doubling the energy density for portable electric devices. By using that contract manufacturing model with Flextronics and Selectron, we'd actually make the batteries where they make the cell phones. So that was a basic idea there. And of course, whenever you're pulling a deal together, you have a very aggressive, probably unrealistic schedule, but that's what you go with. Key early moves were selecting the right board. Desh Deshpande, we asked him to be our chairman of the board. He is clearly a seasoned, very successful entrepreneur, and we wanted somebody like that in a very senior role in the company to help us through what would definitely be turbulent waters at times. He accepted, so he was the chairman of the board and remains at this time. Jeff McCarthy, who's essentially one of the VCs at Northbridge Venture Partners. There are two types of VCs, the kinds that have been out in the real world and built companies, and then there are the kinds that have gone to business school and read about that. Jeff was the former. He'd been out in the real world and had company. And Paul Jacobs joined us early as a board member, and he's CEO of Qualcomm. So we had a very senior guy from the customer side in a very influential role in the company. Building the right team. I don't know how many of you have worked closely with high-performance technical teams with PhDs and such, but at times it's like herding cats, so I didn't want to herd cats for a living, so I focused really hard on the right kinds of people. We hired 15 guys in the technical team from a pool of hundreds. Building the right culture, capability, teamwork. Teamwork really is a key point in startups. It's all about subordinating your personal ego to that of the greater glory of the team. Flexibility and passion, which passion really means ability and willingness to work impossible hours on a long time frame. So that's what passion means. Finding the right CEO, we got very fortunate here. We have a guy who remains a CEO with us today named Dave View, and he's very broad, engineer early, moved into business. He rode the APC, American Power Conversion growth cycle from 50 million in sales to a few billions in sales over the 80s, and he was in a senior role there. And he took a bet on us early on when we were still a science project, and now that we're no longer a science project, we can really fully utilize his business capabilities. Focusing on the right things, it really is about making sure you don't get ahead of yourself in those early stages. Instead of focusing on strategic business relationships with customers, which can play a role in pulling things along, you got to make sure that technology works. So the first two pieces, demonstrating and productizing the technology, were most important. But we did have a bump in the road. In 2002, with our core team now hired, working on the self-organization idea, we essentially ran into some practical difficulties. And at the time, it was pretty challenging within the company because the batteries that we were making had poor reproducibility, limited life performance. They'd last a couple of cycles and then seriously degrade. Limited power density. You couldn't get a lot of amps out of the batteries that would make themselves. Limited energy density in terms of our ability to really get dense structures that didn't short out. So engineering all those little particles on a nanoscale basis sounds like a great idea, but it's practically a very difficult thing to do. At the same time, there was a surprising discovery over in Yet's lab at MIT. When we had originally licensed technology from MIT, we licensed 3 patents or 3 technologies from Yet's lab. One was a self-organization idea, but one of the other ones was on a new cathode material. At the time, we thought it might be a good choice for our self-organized battery approach, but we kind of put it on the back burner in the company. Yet kept working on it, but he didn't work on it from the perspective of the new battery system. Rather, he just started measuring its characteristics in a conventional battery design. And what he ended up finding is it had surprisingly good power density. Power density, again, is the ability to get amps in and out of the device. And the context here was that the lithium-ion batteries at the time were all focused on high energy applications. And to do that, they made certain design compromises at the materials level and at the device level. Here we had a material, or MIT had a material, we had the rights, that had something with very high power density. So the idea was, well, maybe this would provide an interesting opportunity for power applications for portable power. Essentially, power tools is the easiest way to think about it. We set up a small scoping team within the company, which is a dangerous thing to do in a startup. Once you start splaying, once you start defocusing, you can really run into trouble in a startup because you have limited funds, limited capability, and you really want to stay as focused as you can. But against some of our investors' advice, we ended up forming this small scouting team and moving this idea forward. So the big break on us on the business side came with Black & Decker's selection of us over others in the industry. Black & Decker knew what they wanted. They wanted a cordless power tool that could produce more power than something you plug into a wall. The problem was they couldn't do it with a conventional battery available, either because they're nickel cadmium, which is a very heavy battery for those of you that know batteries. They're like lead acid in a way. Or they were unsafe. So they knew what they wanted. They shopped their spec around the industry. We were the only guys that said we could do it. And to their credit, they picked 20 guys in Cambridge at the time who had a lot of chutzpah, but not a lot of battery experience. So they selected us. They created a program based on our battery technology, and we developed a product specifically for them. In a remarkably short period of time, for those of you who know materials and devices and what it takes to actually come up with manufacturing process based on those, we came up with essentially the key pieces of demonstrating the product that they built a whole new power line, product line of power tools based around. So 33 months from concept to mass production with tools that outperformed the corded counterpart, which changed the game for Black & Decker. Zipping forward to where are we today, I've kind of covered these basic pieces up here. The basic technology that we developed, we saw as a very good transition into the automotive and electric grid area because of the combination of power, safety, and life that improved life performance. We moved into that area. We received very significant funding from the federal government. In fact, we're the largest award winner of federal funds for developing automotive battery technology with this $27.5 million in development programs so far. More significantly, in the last year as part of the stimulus package, we raised $249 million in grants to build factories in Michigan. The basic value prop there is if left to our own devices without this kind of support from the government, building factories in America won't compete with Asia. And so this is really necessary to level the playing field. Every dollar we put in, the feds are putting in $1 for the CapEx to keep our CapEx costs low so that we have an even playing field internationally. So that's a basic reason there. And we did have the great privilege, and it was just incredible as a founder to go down and have your company go public. And so in September of last year, we went public on the NASDAQ exchange. We're not done yet, though. Remember in that last aggressive thing, I said we'd be profitable in 2007? That was a plan. We're not there yet. So the next step for us is to turn the business and make it profitable, which remains our focus as we move into the automotive area.